Now, let's look at how a blowout might occur. 1. The psi of the hydrostatic pressure decreases until the reservoir pressure is higher than the mud pressure. This is called an underbalance condition, and in this condition, oil or gas enters the wellbore. Number 2. Oil and or gas then displaces the mud in the annulus. Since the oil and or gas is lighter than the displaced mud, the mud column becomes even lighter, which accelerates the rate of the fluid influx. Number 3. As a gas kick travels up the annulus, the mud column above it becomes shorter, thus reducing pressure on the gas and allowing the gas to expand, which, in turn, displaces more mud and further accelerates the process of the kick. Number 4. The kick of oil and or gas reaches the surface and blows out through the rig floor. The blowout fluid can ignite, burning the crew and destroying the rig. Fortunately, with modern BOPs and careful monitoring by the driller and his crew, the above scenarios are rare. Every effort is made to anticipate the changing reservoir pressures and to design mud programs to handle these pressures. In development drilling, where local pressures are known, this is relatively easy, but in wildcat wells, where very little is known, this task is a lot more complicated. When drilling wells where pressures are not known, it is usually best to drill the non-permeable sections somewhat underbalanced and then to wade up in the permeable zones. Nevertheless, the crew must be on the lookout for subtle signs that a kick is developing. If a kick is detected early enough, the mud can be waded up and the kick can then be circulated out of the hole. If a kick develops too fast or appears to be gaining momentum, then it may be necessary to close the blowout preventer. When activated, the BOP, sitting just underneath the rig floor or on the ocean floor in an offshore rig, will close, sealing the well, preventing it from blowing out. If a blowout occurs, even with good technology and careful monitoring, the well must be capped. In extreme cases, experts must be brought in to cap the well. Let's review. There are 5 main systems of a modern rig. These systems are composed of the rotary system, which involves drilling and drill bits, the hoisting system that allows heavy loads to be lowered and raised into and out of the hole, the circulating system that controls the fluids or muds that are used to protect the drill bits, the drill string to clean the hole and to prevent blowouts, the prime movers which supply power to the rig, and the pressure control system which cuts off the flow of oil and gas to the surface in the case of an uncontrollable buildup of pressure. So far, we have mostly discussed the tools, components, and the functions found on a rig. It is now time to turn our attention to the men and women, the crew, who keep all of the many aspects of an operating oil well working, drilling for oil. The rig's operating crew are employees of the drilling contractor. They usually work from 8 to 12-hour shifts during the time the rig is operating, which is 24 hours a day, 7 days a week. The person in charge of the overall operation on a rig is the tool pusher. The driller is the hands-on operator of the rig. As the foreman of the drilling crew, he is the person who oversees the actual day-to-day drilling program and supervises the different procedures. Reporting directly to the driller is the derrick man. He monitors the upper area of the derrick that includes the crown and traveling blocks. When required, he is the person that stands on the monkey board for a bird's eye view. His job is to stack the pipe when tripping out of the hole. The rest of the drilling crew are called floor hands, or more commonly known as roughnecks. They perform various tasks that relate to checking and maintaining the equipment on the rig. Roustabouts perform general labor on and around the rig. Big rigs can also have specialists like motormen, mechanics, electricians, etc. they usually report to the tool pusher. In addition, there are people who operate as support personnel. They are on site but are not directly involved in the actual drilling. The company man represents the operating company that hired the drilling contractor. The drilling engineer, who is employed by the operating company, prepares the well plan and provides engineering input as needed during operations. The mud engineer monitors and controls the conditions of the mud. The well site geologist tracks the rock formations by examining the cuttings that come up during drilling. The mud logger monitors the shows of oil and gas in the returning mud system. With years of experience and hands-on know-how, these and others are the people you will meet when you visit a rig. Now let's turn our attention to some routine drilling procedures performed by the driller and his crew. These include procedures known as drilling ahead, making a connection, and round tripping. Let me explain these terms. The job of a driller is very important to the successful drilling of a well, and he is the one usually in charge of implementing and overseeing routine drilling procedures. One of his principal tasks is drilling ahead, turning to the right, or making hole. All of these terms indicate the task of drilling one stand or one length of pipe of around 30 feet or 10 meters at a time. As I explained earlier, once the length of a stand is drilled, the Kelly has to be pulled up and removed while a new length of pipe is added to the drill string. While drilling ahead, the driller is also watching the weight indicators closely to ensure that there is proper weight on the bit, keeping a close eye on the mud pressure of the circulating system, looking for signs of kicks, maintaining the proper rotation speed, and monitoring the drilling rate as well as the power supply. Once a stand has been drilled, a new stand of pipe then must be inserted. Let's look at how a stand of pipe is added to the string and a connection made. Once an additional 30 foot is drilled ahead, the driller stops the bit, raises the drill string off the bottom, and shuts down the mud pump. The drill string is raised in preparation for adding an additional stand of pipe. The Kelly assembly is then removed and placed in the rat hole. The next stand is pulled out of the mouse hole after this pipe is attached. The Kelly is reconnected and the drill string is lowered back into the wellbore and the rotating bit resumes its work. This is done over and over again until the rotary bit reaches the target. These are complicated tasks requiring teamwork and precision. Also, because during the time that the Kelly assembly is off the drill string, the chances of a blowout increase, so the team wants to complete this task both rapidly and accurately. Let me mention that when using a top drive, the entire stand, or about 90 feet, is drilled down before having to attach more pipe. Using a top drive, of course, shortens the drilling time significantly because every connection takes time, and as you can imagine, making one connection takes less time with a top drive than 3 connections with a Kelly assembly. To add joints or make a connection, specific tools are used. These include slips, tongs, and elevators. When the drill string is first brought out and while the Kelly assembly is still attached, the drill string is placed in slips. Set by the roughnecks, the slips give the driller a place to suspend the drill string while more pipe is added. Meanwhile, the Kelly assembly, with its bushing, swivel, and rotary hose, is swung over to the mouse hole where it is connected to the new stand of pipe. With the tongs, the Kelly assembly is tightened to the stand. Then, the Kelly assembly and the new stand is then stabbed into the top of the drill string, and again the tongs are used to tighten the new stand into the drill string. The drill string is now lifted, the roughnecks remove the slips, The mud pumps are restarted and the bit is run back to the bottom of the hole, and as rotation is resumed, drilling begins anew. This process is repeated over and over for thousands of feet until the target is reached. These are the basic steps used in making a connection. Round tripping, or making a round trip, is the process where the drill string is pulled out to change the bit, add drill collars, add directional drilling equipment, etc. Round tripping, therefore, just describes the act of taking out and putting back the drill string for a variety of tasks. In round tripping, the Kelly assembly is removed and stored in the rat hole. A special piece of equipment called the elevator is connected to the hook and pipe is pulled out. The term tripping out is used if the drill string is pulled out for a different procedure, like when logging is being done. When they trip out, a large stand of pipe, usually about 90 feet, of the drill string is pulled out at a time and stacked in the fingerboard. It is the job of the derrick man to stack these stands of pipe in rows like these. Let's review. Drilling ahead, making connections, and round tripping are all complex operations involving many sequential steps that must be repeated over and over again. The driller, the derrick man who stands on the monkey board, and the roughnecks must all work together to complete these difficult tasks. Of course, the support personnel participate according to their expertise. In the last decades, many of these procedures have been automated for safety. Because rigs have a useful lifetime of 30 years or more, the automation of any particular rig will depend on its age. When working on a rig, you'll find state-of-the-art technology as well as older technologies depending on the age of the rig and its history of its retrofitting. You will want to be prepared for all types. Regardless of the experience and careful planning that have gone into drilling a well, things can still go wrong. When we discussed blowout preventers, we discussed how pressure within a well can become underbalanced to cause a blowout. Remember, underbalanced pressure means that the hydrostatic pressure in the borehole is less than the formation pressure. Other, less dramatic events can also occur that can impede progress.